In this video, we will be showing you how to perform a series of dilutions from stock solution and how to calculate the density of the diluted stock solution. Before we begin, we need to establish the definition of a stock solution and dilution and relate these terms to the dilution equation. A stock solution is a concentrated solution that can be diluted to a lower concentration. A dilution is the process of reducing the concentration of that stock solution. A stock solution and dilution are related by the dilution equation, which is C1 times V1 equals C2 times V2. C1 is the concentration of the stock solution and V1 is the volume of the same stock solution. C2 is the new concentration of the diluted solution, and V2 is the volume of the diluted stock solution. V2 is found when you add water to the existing stock solution in a container until it reaches a certain volume. Before starting your dilution, make sure to wear your lab goggles, a sleeve shirt, and long pants. Also be sure to wear closed-toed shoes. Now we can begin the lab. First, we begin by pouring an amount of stock solution into a 100 milliliter beaker to use for pipetting. Next, we poured an amount of blue water into a 100 milliliter beaker to use for the dilution process. Before pipetting any solutions, you must first prime your pipette by rinsing with blue water 3 times, then stock solution 3 times, to remove any water left behind that could potentially affect our dilutions. Next, draw the stock solution into the 10 milliliter graduated pipette by squeezing the bulb and placing it on top of the pipette. Then remove the bulb and place your finger over the top of the pipette to keep the solution from flowing out. Then read the initial volume at the bottom of the meniscus as you hold it at eye level. Record the volume to 1 degree of uncertainty. A meniscus is the downward curve of a liquid in a glass container. A meniscus occurs because the molecules of the liquid are more attracted to the walls of the glass container. This phenomenon is called adhesion. Next, transfer the stock solution into a 25 milliliter volumetric flask. Record the final volume of the solution in the pipette. Use a balance to determine the mass of the stock solution by subtracting the mass of an empty volumetric flask from the mass of the volumetric flask containing the solution. This will be used to find the density of the stock solution. Using the same process for pipetting the stock solution, draw water into the pipette to dilute the stock solution. Transfer the blue water into the volumetric flask containing the stock solution until it reaches the 25 milliliter mark. Next, using the balance, find the mass of the diluted solution. Then subtract that mass by the mass of the empty volumetric flask. After performing 3 trials of dilutions, here is the final dilution in the 25 milliliter volumetric flask. We recorded all the initial and final volumes and masses. Using the dilution equation, we found the concentration and the density of the diluted solution. After performing your dilutions, it is important to wipe down your lab bench, pour excess reagent down the drain, and clean the used glassware with water.